Question number 3. Velocity distribution for laminar boundary layer is given as sinusoidal. Determine the velocity profile using appropriate boundary condition. In this question, it is similar with the question number 2. You need to derive your own velocity profile, but that velocity profile must be a sinusoidal profile. Then at the same time, you need to use appropriate boundary condition. So what is boundary condition? It was explained in the previous videos while we solving question number 2. For sinusoidal patterns, so the basic term for sinusoidal pattern is u is equal to a sine by plus c cos dy. So in this general equation, we found that there are 4 unknown parameters. So means that, get ready, you need to have 4 equations to solve simultaneously to get all of this value. But it is okay, we fix to our, let's back to our boundary condition. So at point number 1, which is y equal to 0 and small u is equal to 0. We substitute the value of this into this general equation, we could find that the value of c is equal to 0. Then we could simplify this velocity profile into u equal a sine by. At this stage, we could say that any value of d will not affect in this equation because the value of c is equal to 0. So means we only now we could only use 2 equations to find a and b without knowing what is the value of d because the c is already 0. At point number 2, we could say that y is equal to delta and small u is equal to capital U. So at this stage, we substitute the value into this. In this equation, we could say that capital U is equal a sine b delta. We name this equation as equation number 1. So at the same point, at point number 2, we could have the third condition, which is at y equal to delta, du over dy is equal to 0. So again, we substitute in this equation u equal a sine by. So from this equation, we could have its du dy, which is ab times cos by. We substitute the value of y equal to delta here, and finally we could have this term. We solve that term, we have 0 equal cos b delta. So we find that cos equal to 0 is equal or occur at pi equal over 2. So we equalize this b delta equal pi over 2. We could say that b is equal to pi over 2 delta, and we name this term as equation number 2. So from both equation 1 and equation 2, we could say that u is equal a sine b delta. We substitute the value of a here and we substitute the value of sine. So by knowing that sine pi over 2 is equal to 1, so we could say that u is actually equal to a. Then from the basic equation of u equal a sine by, we substitute the value of a equal to u here. Then we could say that the final velocity profile of sinusoidal profile is sine pi over 2 y over delta. So this is our final answer. Please subscribe this channel, C23 Classroom channel. Thank you for watching.